Wise Guys Wednesday. Today we discuss how a forehead thermometer works by detecting the radiation that's emitted. U of I Professor Paul Kwiat is filling us in this morning.
Good morning, everyone. Nice to see you again. It's been quite a while. I hope you're all doing well. Today, and actually for the next couple weeks, our goal is to try and understand a little bit more about how this thing works. This is just a forehead thermometer. And of course, how it works is that we just put it close to, but not touching our forehead, and I hit the button, and it tells me that I'm currently 98.4 degrees. It also requires you to be a particular distance away. So if I'm close, it works, but if I get too far away, it just gives me this error that's saying that it's not actually working. So let's try and understand how that happens and what is this actually measuring to get our temperature. So let me just share the screen. So this actually comes back to something that we've talked about before, which is that whenever I have a hot object, then the electrons moving in an object will emit thermal radiation, electromagnetic radiation, and the hotter the object is, the higher the temperature, the shorter the wavelength will be. So if I have something like the sun, it's actually emitting peaked at the green, pretty long wavelengths, and if I go to something that's not as hot, then it'll emit more into the red, and if we come all the way down to us, then we're actually emitting in the infrared at something out like 10 microns. So we can do just a quick demo of this using my stovetop. Let me stop the share and set this up here. Okay, so this is the burner on my stove, the back burner on my stove over here. And I'm just going to turn the heat on this, and we can see that it's starting to glow. Now, to me, it looks red, even though on the camera it looks a little bit more purpley, but we can definitely see that it's turning red here. And that's because as it's heating up, it's no longer emitting in just the infrared. Now it's emitting primarily in the red so that I can see it. Okay, so let's come back to us, come back to me, and come back to my slide here. Okay, so if I want to measure the temperature of a person, I don't want to measure in the visible because we're not really emitting much in the visible. We're emitting out in the infrared. So what my thermometer is going to do, it's going to register how much power is emitted at around 10 microns, for example. Okay, but in order to really get the temperature, I need to look at something a little bit different. Not just the color, but how much power is emitted. And it turns out that the power that's emitted by a hot object is very sensitive with the temperature. So it varies with the temperature to the fourth power. And I've plotted that here. And let me just zoom in. This is over the entire very large range of temperature. But let me just zoom into something that's relevant for us. So something, say, from around 80 up to 105 degrees. And we see that it really makes quite a big difference whether you're at, for example, 98 degrees or 101 degrees. There's quite a big change in the power. What I'm showing here is the power in watts that's emitted by just a centimeter patch, say on your forehead, and it's actually pretty high. It's something like 50 milliwatts. In fact, if you take the total power that is emitted over your whole body, of course, it depends what the surface area of your body is, but it's something on the order of 1,000 watts. So you're sort of constantly emitting 1,000 watts. That's one of the reasons you have to eat, is to be able to support the amount of energy that you're leaking away all the time. Okay, so if I measure the power, I can get a sense. I can then calibrate that to figure out what the temperature is. But there's one other thing that we care about, which is not just the power that's emitted, but actually how much power we're collecting. So I've shown here, this is a model of just like a patch of skin on my forehead. And I've got the detector, and depending on how close the detector is to that patch, it's going to collect a different fraction of the power. So in fact, as it gets to be pretty far away, this patch looks kind of just like a point. And whenever I have a point source, I think about the energy just spreading out like a sphere, and the surface of that sphere goes like r squared, the distance that I am from the center of that. And therefore, the power is going to drop off like 1 over r squared if I'm far away. And I don't really want that, because that's a very, again, pretty sensitive to exactly what that distance would be. On the other hand, if I'm very close, if my detector is very close, if R here is very small to this patch, then I don't really notice the fact that there are edges. And let me just zoom in. Instead of going from 0 to 5 here, let me go from, say, 0 to 0.5. We see that then the power is basically constant with the distance. Okay, so let's come back to our actual device here. And I can do one other kind of fun demo. So this actually has two sensors. So the one on top, that's the one that's measuring how much infrared power there is. And then there's this one on the bottom. And the purpose of the one on the bottom is just to determine what how far away I am from the surface. And we can deactivate that in a sense, or we can spoof that just by putting a piece of tape over it. So that's all I'm going to do here. Put a piece of masking tape right over it. Okay, and now, if this is very close, it says I'm 96.6. As I get further away, though, 95.6, 92.8. So we see that now it's dropping 89.9, and then it's going to stop working soon because this only registers from around 90 degrees up to 110 degrees. So it gives an error if you're outside that range. But we can definitely see that the intensity is dropping. But if I'm really pretty close, the intensity is not really going to change very much. And so that's why they say, well, try and keep this about an inch away. That's what it's calibrated for. Okay, and I will say the same thing works in an ear thermometer. It also looks at the infrared, but in that case, your distance is sort of fixed anyway, so you don't really have to worry of exactly how you're holding it. So we will look at some other interesting stuff with this in the weeks ahead. I hope to see you, and I hope you have a great week in the meantime. Bye-bye.